continue with example 3. This is the question. Integrate from 0 until 1 for 1 over 1 plus x squared dx. So this form here shows that we need to do trigonometric substitution. So let's stick it here. So 1 plus x squared is equal to a squared plus x squared. So your a now is equal to 1. Now let our x as a tangent theta. So since your a is 1, therefore x is tangent theta. So let's do this. When x is tangent theta dx, differentiate this. This is secant squared theta d theta. And then let's change our limits. All right. So since we have a limit, so we need to change our limit so that later on we don't need to change back to x. We need to just fill in the limit. So when your x is equal to tangent theta, therefore theta is equal to inverse tangent x. So let's put in our limit. When x is equal to 0, theta is inverse tangent 0. So this is just equal to 0. And another one, when x is equal to 1, therefore theta is inverse tangent 1, which is pi over 4 radian. So let's change everything in the question to be in terms of theta now. So your new limits from 0, 1 is now 0 pi over 4. And here the function is 1 over 1 plus x squared squared. So this is 1 over 1 plus tangent squared squared. And your dx is equal to secant squared theta d theta. Let's just substitute this here. So now let us focus to change this in terms of trigonometric identities. 1 plus tangent squared theta is just equal to secant squared theta, and the rest remain the same. So now let's simplify. This is squared and this is squared. So this is power of 4. Let's cancel out with secant power of 2. Now let's just simplify this. Secant squared theta divided by secant to the power 4 theta. So just cancel out the square here. So you're left with 1 over secant squared theta. So 1 over secant squared theta, this is just equal to cos squared theta. So we know from the previous chapter, cos squared theta, if you want to integrate this, you need to change it using identities. So let's replace this with half 1 plus cos 2 theta d theta. So now this is a constant, take it out. So let's focus to integrate 1 plus cos 2 theta d theta. So let's do this. Let's expand this first half, integrate 1 d theta plus half integrate cos 2 theta d theta. Don't forget to write in the limits. So let's do this. Integrate this is theta and just write back your half plus half, and integrate cos 2 theta is sine 2 theta over 2. And let's put in all of the limits here. So now let's put in our limits. So this should be half. So put in pi over 4 minus 0 plus, let's take out the constant 1 over 4. So sine 2 theta, let's fill in with pi over 4. So this is sine pi over 2 minus sine, put in 0. So this is sine 0. So let's solve this value here. 1 over 2 times pi over 4. This is pi over 8. Then let's solve this one. 1 over 4. So sine pi over 2 is 1. Sine 0 is equal to 0. Therefore, this is your answer, pi over 8 plus 1 over 4. So let's take out the constant 1 over 8. So inside the bracket, you are left with pi plus 2. Therefore, this is your final answer.